The ambiguous case is a new topic that wasn't in GCSE because they avoided questions where it might occur. It's something new to A-level. And it affects us when we use the inverse sine or arc sine function. If we look at the graph of the sine function, you'll see I've got angles here at the bottom and the values of sines of those angles on the vertical axis. And the graph itself rises up from, at an angle of 0, it is 0, to an angle of 90 degrees where sine 90 is 1. That then falls off again, so that down at sine of an angle of 180 degrees we're back at 0. That means there's a pair of angles that actually deliver us the same value of sine of those pair of angles. For instance, if we look at 30 degrees, sine 30 on our calculator is 0.5. On the graph, we can see that. But also, if I take sine of 150 degrees, that is also 0.5. So there are two angles that deliver me the same sine. Those two angles always occur in pairs, and the pairs will add up to 180 degrees. So for example, if I was looking at the sine of 60, then the paired angle for that one will be 180 minus 60, which is 120. So 120 sine of that should be at the same height, and you can see that there on the graph, somewhere between 0.85 and 0.9. That's fine working forwards because we know the angle and we're doing sine of that angle. However, if we're working backwards and I do inverse sine or arc sine of 0.5, the calculator tells me the answer is 30 degrees. And indeed, that's correct. That is correct in that there is an answer of 30 degrees. However, we know now there's actually at least two answers where the inverse of sine is 0.5, and that we have to think about because the calculator isn't going to tell us. So in this case, we know the other answer is 150. So whenever I'm doing questions on these, I have to consider the calculator's answers will be in the green zone, will only give me answers up to 90 degrees. But I have to consider 180 minus that answer as another alternative answer that could exist. It won't always exist. For instance, if in my triangle I already have an obtuse angle, one above 90 degrees, I clearly can't have a second obtuse angle because that would be two angles above 90 degrees, and so the sum of the angles would be above 180, which isn't possible for a triangle. If we look at a typical question where this might occur, so in this triangle PQR, we're told PR is 6, QR is 11, and the angle PQR is 30 degrees. Now note that angle is not the angle between these two sides because the intersecting point is R, not Q. If I work all this through, the calculator tells me the answer for angle P would be 66.4 degrees. And indeed, that is a perfectly plausible answer. You'll see all the information we were given is shown here. However, as we've now seen, this isn't the only answer, because if I do 180 minus 66.4, that tells me another possible angle is 113.6, and that would actually look like this. So you now need to think, every time you do inverse sine on your calculators, is there another possibility? If we overlap these two triangles, you'll see the two possible options together, this smaller triangle and then this bigger triangle. This one here is always an isosceles one, as these two sides would effectively be the same length, and that's quite nice to see the two together. And it sort of gives you a bit more of a reasoning as to why this angle is 180 minus this one, because of course in an isosceles triangle these two are the same.